the farm-raised striped bass that arrive at wholesale markets or that are served in restaurants begin life some 18 months before in hatcheries under controlled conditions. Here, the eggs of mature females, called broodstock, are removed so they can be fertilized with sperm from male striped bass, or the sperm of white perch or white bass if hybrids are to be made.
All right, lay it down. Bob, start fertilizing. White bass.
While broodstock can be reared in captivity, it is more common to capture these mature fish during the spring migration on their natural spawning grounds. There are several ways to collect striped bass. They involve various forms of netting, hook and line, traps, and electrofishing. Electrofishing, which makes use of electrical current, is one of the better methods because it is less stressful to fish. And your most important consideration in capturing broodstock is to minimize stress. Stress can impact the maturation of eggs and ultimately spawning. With electricity, fish are harmlessly stunned for a short period and can be brought aboard without struggle. Unlike capturing striped bass by hook and line or by gill netting, in which fish will naturally struggle to escape, electrofishing disables the fish quickly and safely. In addition, electrofishing gives stripers a better chance of recovery, which is especially important if they are to be returned to their native river after spawning. Once fish are aboard, various measures can be taken to minimize any further stress due to confinement. For example, bubbling pure oxygen into the tank can help. So will the addition of salt to the water, which can offset the blood salts a fish will lose under stress. Anesthetics can also be of value in preventing fish from fighting inside the small space of the tank. At the dock, fish need to be transported to the hatchery efficiently and with as little handling as possible. The transport tank should be maintained at the same salt concentration, temperature, and oxygen level as the holding tank. Success of striped bass spawning in the hatchery has been based on the use of ovulatory hormones, such as human chorionic gonadotropin, which speed up the process of egg laying. Striped bass collected from their spawning grounds should be close to producing eggs and may need only a push from such hormones to spawn under hatchery conditions.
Yeah. What's this? Get her in there.
Yeah, she's in the hoses. There you go.
All right, let's check her.
To accurately predict when a fish is going to ovulate or spawn, a small sample of eggs is removed and examined under a microscope. A glass catheter is inserted into the vent or genital opening, and a sample of eggs is removed. By comparing the stage of egg clarity against known standards, you should be able to stage the eggs, that is, to predict how far the fish is from spawning. It is very important to get this prediction right. Eggs taken too soon before ovulation, before they have separated from the ovarian walls, will not fertilize. Eggs taken too long after ovulation will begin to deteriorate because they no longer have a supply of parental oxygen. Eggs of fish more than 15 hours from ovulation are not distinctive enough in appearance to accurately estimate their stage of development. Here are various stages of egg development, using eggs taken from a striped bass held at 68 degrees Fahrenheit. At 14 hours before ovulation, oil droplets begin to coalesce or unite into globules. While the eggs transmit light, they are too diffuse for us to see distinct shapes. 9 hours before ovulation, eggs are becoming transparent and are now less adhesive to each other. The oil globules are more clearly single entities. By the 5th hour, egg transparency increases while the egg's outer membrane, the chorion, is still rigid. As ovulation nears, the degree of egg clarity improves. In addition, the chorion becomes more flexible. Ripe eggs are probably the easiest to identify. They are completely transparent. The oil globule has a greenish tinge, and most importantly, the chorion has become so flexible that the eggs will form a hexagonal shape as they compress next to each other. For accurate prediction, it is important to hold fish at water temperature between 66 and 68 degrees Fahrenheit.
Is she the only one in here?
If, for example, you predicted a striper to be 6 hours from spawning, but the water temperature is 62 degrees Fahrenheit, your prediction could be off by as much as 4 hours. If you are going to produce striped bass and not hybrids, male and female fish can be placed in the same tank where spawning and fertilization can occur naturally. The fertilized eggs can then be drawn off.
Let her down, let's get the sling. She's close enough.
In producing hybrids, however, it is necessary to physically remove the eggs from the female so that they can be fertilized by sperm of the other species. Once you have determined that the fish is ready for spawning, it is often best to sedate her by applying an anesthetic to the gills. This will relax the fish during ovulation and prevent her from damaging herself and the workers. The most common technique for egg removal requires 3 people. One person holds the head, another the tail, and the third manually removes the eggs by palpitating the stomach so that the eggs flow into the pan themselves. In general, a mature female striped bass will produce 100,000 eggs per pound of body weight. A large striper such as this one may produce as many as 2 million eggs. Once the fish has been spawned, she is placed back into a recovery tank for eventual return to the river system from which she was taken.
We need another dry towel.
A number of males are used for fertilization when you are producing hybrid fish. In this case, striped bass eggs are being fertilized with sperm from white bass. Because they are small, these males do not have to be sedated. If the fish are larger, for safety reasons, you may want to anesthetize them. There are several ways to effect fertilization. In the dry method shown here, sperm are added to the eggs directly. This mixture is then stirred with slightly saline water, about 5 to 10 parts per thousand salt, at the same temperature as that at which the fish were being held. The addition of water and stirring causes fertilization to occur. For fertilized eggs or embryos to develop and hatch normally, they should be incubated in water temperatures between 62 and 70 degrees Fahrenheit. At 68 degrees, the incubation period from fertilization to hatch is about 42 hours. During this period, eggs need to be constantly moving to keep from settling out and being subjected to low oxygen levels at the bottom of the tank or jar. Because eggs from striped bass in the Chesapeake Bay are very buoyant, the incubation chamber needs to be a tank of some kind so that the eggs can float and stay in suspension. Eggs from striped bass in systems other than the Chesapeake can be incubated in McDonald hatching jars, cylindrical jars that can take about 150 to 200,000 eggs per container. In recent years, Hatchery operators have been working to produce striped bass and hybrids that are, in effect, sterile. Such fish are called triploids. The value for fish farming is that the food these striped bass feed on will not go towards development of reproductive organs, but will be channeled primarily towards growth. One way to produce triploids is by a mechanical process that pressurizes the eggs immediately after fertilization and results in fish having 3 sets of chromosomes instead of the normal 2 sets. While production of triploids in grass carp, salmon, and some trout has been successful, it is a relatively new process with striped bass and its hybrids. The ultimate success of this artificial manipulation is still unknown. Normally, fertilized eggs go through a process of cell division from 2 cells at approximately 2 hours to 16 cells at 3 hours to 64 cells at 4 hours. By 8 hours, the early blastodisc, the disc-like region from which the embryo begins to develop, can be observed. Near the end of the first 24 hours, the developing embryo can be discerned. During this incubation period, non-fertilized or dead eggs leave an oily film on the water surface that can cut down on oxygen transfer. In tanks with buoyant eggs, absorbent pads should be used to remove this oil. After hatching, the striped bass and hybrid fry, also called sac fry or prolarvae, are placed in an aquarium or any container with sufficient water flow and oxygen to keep them suspended. These newly hatched fry do not have complete mouth parts and depend on their yolk sac for nourishment. They can maintain themselves for up to 5 days on their yolk sac. By the 5th day, striped bass and some hybrid crosses are capable of accepting feed. It is now that they should be stocked in ponds. If the fry are not stocked in ponds by the 5th day, where they can feed on natural stocks of zooplankton, they will need to be fed artemia, microscopic-sized shrimp that are reared from dried eggs. Fry are extremely sensitive to handling and other stresses, especially changes in temperature, dissolved oxygen concentrations, pH, salinity, and alkalinity. With proper packing and sufficient oxygen, fry can be safely packaged for shipping to fish farmers for grow-out. Fish farming begins where hatchery operations end. While the long-term profitability of striped bass farming depends on growers who manage their ponds well, the most successful farmers are only as good as the fry they start out with. And high-quality fry are only as good as the hatchery operation that produces them.